Okay, this is an example of the um, network layout that I've built that I keep talking about in various videos. This is a visual, and I'm going to go through an actual deployment cycle so you can see what it looks like. Here I have my crudely drawn layout of what things are going to be. On the top left here, we see, let me make it full screen here, our happy little user up in the top here. There's our user. It's going to go to site.crojibright.com. It could be whatever site. Here we're going to have an ALB that's going to go to an ECS cluster, and that's going to talk to some database stuff on the back. What you see here on the right of the ALB, VPC load balancer, what I'm doing is calling out the VPC that this is going to be in. And so that's different from the application VPC, and normally when we get an AWS account, we get some default stuff, a default VPC, default subnets. I'm sorry, I just realized I used the word VPC when it should actually be subnet. Sorry about that. I'll fix it later. These are all subnets, so the ALB endpoints live in the subnet load balancer. Sorry, I made this in a hurry. The subnet application will have the EC2 instances and so on and so forth. So we'll have monitoring, security, and bastion, as well as data and cache. So all of those are different subnets, they're different CIDRs, they're separate from each other, they can have their own individual route tables, ACLs, all that stuff. The reason for doing this is because of this idea of a blast radius. I had one client at one point who, instead of having a monitoring VPC, they had something like a management subnet, and what they did is they put their Jenkins master and build agents in that subnet, and then it could talk to a bunch of stuff. The problem was one of the contractors left all TCP open to 0000, 0000, or 0/0, and the Jenkins master got compromised and turned into a Bitcoin miner. Now, if it wasn't a Bitcoin miner, if it's like Netcat or something like that, then potentially you could infect the rest of your network by going to the other subnets. And so we think of that as like a bomb, and then you have a blast radius that bomb impacts. So if we lock everything down to individual subnets, then that blast radius is reduced. If we use NACLs, it's reduced even more. Subgroup security groups, it's reduced even more. And so the idea is that we want to try to get that blast radius as small as possible. If we use the default subnets and VPC that is provided by AWS, that's perfectly fine, but everything ends up being in the same kind of lump. And so the blast radius is bigger, but then we kind of reduce it with security groups, which is good, but you know, in enterprise environments, they do this in the data center for the same reason. And so this kind of looks like something data center people will be very familiar with. And we'll see how this kind of plays out here in a minute. So that's the basic idea behind the design. You can see we have like a subnet for security, one for monitoring, bastion, and then you can kind of see the little lines a little bit better. The ALB and the bastion instances, or the ALB endpoints and the bastion EC2 instance will go through the IGW, the Internet Gateway, because they're public. And so anything that's marked as private, like the ECS cluster or the EC2 instances that make up the ECS cluster, your Redis nodes, Postgres, or anything in RDS that's tied to these, anything in monitoring and security, will be route through the NAT gateway. And all it means is like those resources in the back end are not going to need to talk to the internet unless they're doing like package upgrades like apt-get or something like that. So we really don't need to worry about that too much. NAT gateway is just more convenience. The ALB and the bastion, obviously very important that they have an internet gateway. I'm going to get into stuff. Okay, so here we start off with just a blank slate, and I'm going to go ahead and deploy network dev, and while I'm doing that, I'm going to show how this works. Okay, so the stack is creating, and I'm going to go over what it's going to create here. This is the YAML file that I use. I have a toolkit that does a lot of cool stuff. The idea is that this is just one toolkit in a wide, beautiful array of other toolkits that do cool stuff. There's a Python rig that allows you to do like CloudFormation stacks, but like each element is an object, and you treat the whole thing as like a chain of objects. It's really cool. I think there's a Ruby component that does the same thing. The idea here is to kind of see one other approach. It's not necessarily designed to be implemented in your organization. You can try if you want. I don't have a problem with that, but this is kind of like my playground to play with ideas. So this is spinning up. As you can see, it's creating a lot of resources, lots of subnets. Everything is tagged, so we don't really care what the name is. You can see like subnet 23. We don't really care about that because what we're going to see is everything gets tagged, and that's how we kind of bring things up. So we'll see we'll have two VPCs. We have the dev VPC here. It's tagged with version 060. And you can see that stack name is tagged as well. So there's tags, lots of identification. We'll get into that in a minute. Okay, we go look at the subnets. Now we'll see a whole bunch of subnets, and we'll go ahead and lock ourselves down with a dev. Boop. Okay, so here we see 6 application subnets. What's happening here is the Ruby code that I wrote goes out and looks at AWS, or asks AWS rather, how many availability zones do we have? Like, and what are they, and what can I use? And so it kicks back a big list of stuff, and we pull out 6 elements from that. US East 1, A, B, C, D, E, F. So A, B, C, D, E, F. Yeah, 6. So application gets 6. Bastion gets 1. The reason we know that is because here we're saying cross zone equals false. We're also saying useNat equals true, public use is true. There's little tunings we can make. And small and medium here just determine the CIDR block that we're allocating. So you can see the application is a medium, so you get 507. There's a few that are reserved for the networking. Bastion gets 250. You see the other ones are getting 251. There's an EC2 instance that gets spun up in here, or sorry, it's not there now, but the NAT actually uses an IP in this space. So that's why we have 1 reserved already. It'll be 249 if I fire up the Bastion stack, obviously. So then we have public load balancer, data, cache, all that stuff. Okay, so create complete. We look at the route table, we see 2 routes, well, 3 technically, there's a default. But what we're doing is making 2 that one's public, one's private. You can see the private default gateway goes through the NAT, which lives in the Bastion, and then the public lives. The public default route goes to the IGW, and then we see the subnet association. So public load balancer and Bastion are part of the public route table. Then private, everything else basically part of the private. Then internet gateway and stuff like that. Okay. So the next step is to create a cluster, an ECS cluster. So we're going to go modify the ECS YAML here, and we're going to tell it to use the 6.0 version of the networking. And then we're going to fire that up. Right there. So we'll say 6.0 ECS dev. That's going to go. And I'm pretty sure this is going to fail because I have some cache left out. So this is actually good. What I want to do here, I just have a really simple local file cache that I use so I don't have to keep hitting the APIs all the time. Okay, so here we're seeing I'm trying to spin up the 060 stack, and it's in create failed. So it will normally try to update it. But what we want to do is bump the version so we can get a new stack. And what I'm doing here is kind of showing off why we use version stacks. I've seen people in enterprise professional environments like not do the version thing and sit here and waste a bunch of time waiting for the stack to come down. So if we just start with this idea that we're going to version our stacks, then we automatically get this ability to kind of rotate through pretty quickly. And I forgot to do. So now I made a mistake. Mistakes happen. We associate for that or compensate for that. Okay, now we're gonna have another stack, and away it goes. So now I don't have to wait for these stacks to get torn down to use the name again. I could just, zip right through. And so this is looking a lot better. This allows you to do like more complicated things. If you change your user data or you change a security group or something like that, you can do an update if you want. But I prefer to do an entirely new stack because that makes sure that everything works the way I expect it to, like start to finish. It's like the ultimate end-to-end test. Okay, so that's going to fire up. And while we're waiting for that, I'm going to go take a look at my service. So the way this works is kind of like if you want to think of it like a sandwich, you have the bread and the meat and cheese and whatever. We laid down the ECS service, and that's going to have the EC2 instances and some security groups and the ECS cluster and stuff like that. And then on top of that, we're going to put an actual application that's going to run. And so we need to say this is going to be cluster version 062, and you kind of see how we have like a dependency. So this service is going to depend on something else. And so we're saying that the something else is both the networking here at this version and the ECS cluster at that version. So I could do a lot of tuning if I wanted to spin up a new version of my service on a different version of the ECS cluster that lives in a different version of the networking stack. Like I can do that. I can tune those things around. It takes a little effort, but okay, and we're going to launch 6.0 of Misty Dev. Shouldn't have to delete any cache, should automatically be cached. And it's possible that it's actually going to fail, because this isn't done yet. So there's a bit of a software bug there that I should take care of. Should wait for that stack to be done before I can launch it, or if it's not there yet, like catch that as a conditional. But we can go take a look at that. And we might have our security group set up too. Okay, cool. So there's two different ways of doing the security groups. You can do like security groups where you have one security group sort of at the top level, and then you add other group references to this. I prefer to do CIDR blocks. They're not quite the same thing. Security groups locked down by the instance is tied to a security group or the load balancer or whatever. I prefer to do CIDRs because I think more people understand CIDR blocks, and I guess it really comes down to, do you want to look at security group IDs or do you want to look at CIDR blocks? And my little monkey brain likes CIDR blocks a little bit more than security groups. There's also, if you do it the different way with the security groups, you end up with way more security groups to manage, and it can be kind of tedious, a little bit more difficult. So let's flip over to ECS. So here we see our brand new cluster. It's spinning up. Probably doesn't have any instances in it yet. Just waiting for the autoscale group to kick over, and we can watch that. So here's the T2 small, it's initializing, doing the user data. Everything's in autoscale group. We also should have at some point, this feature called ECS CWT capacity. And this is explained in this blog post up here. Let me just let's see here. If we go down to, I think it's this guy. This is a CloudFormation stack that has some triggers, and I can show you what this means. Okay, there's a scale up policy, a scale down policy, and then a bunch of CloudWatch alarms for like mem reservation, high, low, mem CPU or CPU reservation, high, low. What these are doing is looking at the cluster capacity and not the usage. So you could have 100% CPU usage and these wouldn't trigger. But let's say, I have a graph here that explains this. If you have 20% 24/8 CPU available and 0 reserved, and then you implement an application, and that application uses 1024, so you have 1,000 CPU reserved and 1,000 available. That's 50% capacity. If you tried to do another deployment, you would allocate the rest of the 1024 and you'd have 0% capacity. So that would trigger the alarm and say it's over 75% capacity. So go fire off and give 3 more EC2 instances to the cluster, and then you have more capacity. And then as time goes down, or time goes on, if the capacity of the cluster is below 50% for an hour, then take an instance away. So that gives you lots of capacity right away to do your deployments, and then takes the capacity away slowly as you don't need it, or as it thinks it doesn't need it. Okay, all right, so our cluster is complete. Wasn't too painful. So now we're going to try this again. I might have to flush the cache again. Yeah, it looks like a cache flush. Yep. Whoop. Okay. Alrighty. So now that's going to spin up. What we're going to end up with is this guy. Failed. That's okay. And I believe we'll have 2 of these. So if I go look at the Route 53, I believe, yeah, okay. So that's the old record. You can see the last iteration I did was 050. We're working on 060 now, so that's going to go do its thing. So we're going to get another Route 53 entry here. And what we're going to do is like the site will actually keep failing until I change this. So the current weight of this entry is 100. Since there's only one entry, it's getting 100% of the traffic. A new entry will get created here in a few minutes that will have zero weight. The initial weight is always 0. That way, the new stack can come up. It won't take any traffic until I change the weight. Now, in this case, I don't have an old stack, so it doesn't really matter. That's okay. Then we have our second security group, so everything's just kind of trending away. All right. We can change the name of this too to make it a little bit easier, but we'll do that later. Okay. So everything's just kind of firing up. And we don't care. Okay. So it's creating our load balancer. We can go look at what that looks like. Our load balancers. Okay. So ALB. Oh, I haven't even gotten it done yet. Okay, the ALB is going to be a little bit different. It's still provisioning. Okay, cool. This basically just goes through and creates the listeners, and then we'll see how a listener attaches to a target group, and that target group handles the work of mapping your external ALB entry point to the ephemeral port on the Docker container in your ECS cluster. We map all of that out through CloudFormation stuff. So here we can say port 80, there's my listener. You can have multiple listeners, and you can actually have our ELBs and ALBs is the same as far as the listeners, but what I meant to say is you can have different rules. So you can have a rule for /products, /King Arthur, like whatever. Like all these different things. But let's see. We take a look at the target group. Sorry, what I meant to say is /products can go to the target group known as /products, and it kind of works like a Nginx routing layer or HA proxy routing layer where you have an entry point and a reverse proxy group. Here we see we have some targets, and incidentally, Google Cloud actually works in the same way. All right, so we have our tasks, and we often look at the stop tasks just to see if there are any, see if it's breaking. Okay, cool. It's initial, good. We should have this guy up. There we go. Now we see 2. One's 100, one's 0. I'm going to I'm actually going to say you're now 0, boop, and you're now 100. I don't know if my face ends up in that. Let's see. So, okay, so there we go. Now, this probably won't work. Oh, it does work. Yes. What you're seeing here is the Misty project, which I've videoed about in other contexts. But let's go look at, so there's the DNS thing, round weighted DNS based on load. So if I had the old stack up, I could switch the weight to like 50-50, and half the traffic goes one, half the traffic goes the other. But let's do something more interesting and look at CloudWatch. I'm just going to zip right through. Oops, wrong one. Okay, we're going to look at the logs. Look at the most recent log. Okay, just for fun, we should have a log entry for this guy. Okay, so we see, there we go. You can see my hits, and this is just Sinatra in the back end, so it's pretty messy about logs, which is fine. You can see here's the actual hit. Pretty easy stuff. That's actually really quick too, so if I hit it again, and then I just sit here. So 5719 and 5818. So it was just that quick. Like, hit the site, the logs show up. So that's pretty cool. Fairly responsive. And so you can see that the site actually works. Like, it's legit. It's running this Docker container. It's doing stuff in the back end. You can kind of see it's it's going to give me some stuff about getting from source. That's actually going and hitting DynamoDB to get information, which is just hitting this. So I should be able to see like some metrics. So there's a read on top. This article's probably going to have more traffic. We should see some reads on this. Right. Well, I haven't hit too many, so. Oh, actually, I haven't hit any articles. So, boop, hit a few there. Boop. Okay. So this should update in a couple minutes and show us some stuff. Okay, so that's basically how everything works. We can see a very secure layout. We can see the target group is healthy, complicated network system. Let's just go back to that and look at our subnets again. Okay. So we see our application now has a couple of IPs used. Public load balancer, we'll see a couple of, two. So one in each thing. So the important thing here is like, there's no way you could manage all of this stuff, like all of these subnets by hand, and then expect to like build out your disaster recovery environment. If you had to do that, there's a lot of friggin' subnets. There's 26 subnets just here. And this is just US East, so it's obviously going to be bigger, but you like managing 26 subnet IDs, 26 CIDR blocks, and like the tags for each one of them and what they're doing and stuff like that, like that's just impossible, or seems impossible. I've seen people try to do it. Like, if I switch this over and did US West 2, I don't know for sure if this works, but the idea is that it should pull the same information from that region and then be able to set up the networking as I've requested, and it would build out 3 of everything instead of 6. So, it should work. Provided like CloudWatch logs, entry point is set up and all that. We also should see, speaking of which, okay, so here we see, this is a good example, memory and CPU reservation is, that shouldn't be an alarm. Maybe that. Oh, it's less than, oh right, less than 50%, so it's fine. And greater than 75, yeah, that makes sense. Okay, so you can see that the reservation of the cluster is coming along. What that means, that those metrics are being taken from here. So we see 2 container instances, and one running tasks. And so if you added up the available CPU, which would be 2048, and we've allocated 524, the memory available, same thing. It looks like a quarter of our cluster, 25%-ish, which kind of lines up with what we're seeing here. Now it's 10% of memory, 20% of CPU, so ish. Let's see. Yeah, tiny little read. Yeah, okay. So that's logging, ECS stuff. Like, it's actually pretty easy. And now the cool thing is, okay, I'm done with the experiment. I know everything works. I was able to test stuff. Like, ooh, cool beans. I don't know what that was there. It seemed like it flashed to a dead page. Might be DNS or something. Okay, so now I'm going to delete everything. Boop, boop. Okay, so there you go. Everything's now going to get deleted, flushed out. Like, everything but that DNS entry gets changed, because if you change something in AWS, it doesn't delete it. It's like if you change something, you've changed the checksum for the unique ID. And so CloudFormation won't delete something if that checksum is different than what it knows it to be. If it in other words, if it hasn't changed, then it will delete it. Interesting point. So then I'll delete the networking. I'll delete everything all down, and then create everything back up. This particular model, the way I'm doing it, absolutely guarantees that if there was somebody that hacked my machine or hacked my environment at some point, like, they're no longer able to get to anything. Kind of eliminating that. Next time I come up, the next time this comes up, the only thing that's shared is my SSH key, which actually, as you can see, wasn't even used. Like, I have a Bastion stack, but I don't use it because I don't need it. Everything comes up the way it should be. And I think that's the way we should run our systems. Like, we don't necessarily need a Bastion machine because things should just work. End rant. Thank you for watching.